Hello again, this is Mrs. Schroeder. We're going to cover the next section of chemistry. The section is section 1 of chapter 9, talking about calculating quantities and reactions. You see this picture is a picture of cookies. What do cookies have to do with chemistry? We're going to learn about that today. We're going to talk about this first one with using proportional reasoning, talk about the mole ratios in a balanced equation, and talk about why mole ratios are used in this word called stoichiometry problems. So as a question I want you to start thinking about is, I have this recipe for cookies. It's calling for 1 cup of sugar and 2 eggs to make 1 batch of cookies. Now it's Christmas coming, you know you want to make lots of cookies because you're having a big party. So you want to make triple the recipe. If you're making triple the recipe, how much do you need of each of these materials? Well, 3 times the sugar. I need 3 cups. If I use 3 cups of sugar and only 2 eggs, my cookies will not turn out very good. I need to make sure I triple both of them. So I need to have 6 eggs. That's how I increase the batch. I have to keep the ratios the same, 1 cup to 2 eggs. No matter whether I triple it, double it, 10 times the amount, whatever I do, I have to keep that ratio the same. The ratios that we're going to talk about in chemistry and stoichiometry, it talks about ratios. So we're going to talk about ratios as mole ratios. So stoichiometry is the branch of chemistry that deals with quantities of substance in chemical reactions. It's similar to using a recipe. I talk about the ratio of the different ingredients to make the food. Stoichiometry, I'm talking about the ratio of ingredients to make the reaction happen. So using stoichiometry, I can figure out the amount of product. If I know that I have 5 grams of copper, I can figure out how much product I'm going to make. I can figure out the amount of reactants. If I know that I want to make X amount of grams of magnesium chloride, I could use my balanced reaction to figure out how much product or how much reactant I need to make a certain amount of product. Byproducts are things that you don't want. Most reactions make 2 things. One is the thing that you're trying to make as the chemist. One is the thing that you don't want to make. But often you can't avoid it. You have to know how much it is so you can deal with it. Stoichiometry will begin with a balanced chemical equation. If it's not balanced, it won't work. The coefficients, or that's the number in front, show the relative number of moles. I have 2 moles of HCl for every 1 mole of zinc. Remember, if you don't see a number in front, it means 1, not 0. If it was 0, it wouldn't be there. We use coefficients to figure out the mole ratios. So when I look at the numbers in front, HCl and zinc, I know that there's 2 HCl for every 1 zinc. So it's a mole ratio. It's just simply a conversion factor. We've been doing that all year long. We know there's 1,000 grams in 1 kilogram. That's a conversion factor. This is the same thing. 2 HCl in every 1 zinc in terms of moles. So simply a conversion factor, we can use that to mathematically solve. For an example, let's say that we have a mole ratio, we're looking for P4 to P2O5. We can see that we have 1 P4 to every 2 P2O5. So if I had 4 moles of P4, 4 of these guys, how many moles would I make over here? Well, should I put the answer in here for you? I would make 8. Mathematically, how did I figure that out? Well, I know that I have 4 moles of P4. And this is a simple one. You can figure it out in your head. They get harder. So I'm just going to show you this one easily. I want to get to P2O4. So there's 1 O5 for every, or there's 2 of those, for every 1 of the P4s. And when I look at these, the P4s cancel out, and I'm left with 4 times 2, which is 8. I'm left with moles, and I'm left with P2O5. So 8 moles of P2O5. And again, starting down here, I have 12 moles of P2O5, and you'll see that my conversion factor works both ways. This time I want to find P4, so I put that on top. The number in front of P4 is 1. I better erase this up here. This is for the previous problem. And the number in front of the P205 is 2. So for every 2, P2O5. Which means 12 divided by 2 is 6 moles is left. And then the P2O5 cancels. I have 6 moles of P4. If I make 12 moles here, I need 6 moles over here to start with. And that's what stoichiometry is all about. Another example, looking at P4 to oxygen. In this case, I'm looking at 2 reactants. If I know how much P4 I have, how much oxygen do I need? It's a 1 to 5 ratio of P2 to O5, looking strictly at the coefficients. So now if I have 4 moles of P4, and I want to know how many moles of O2 I need, I'm going to take 5O2 divided by 1 P4, and you'll see that you need 20 moles. Again, it's simply a ratio. It's like when we had 2 eggs for a batch of cookie, we had to multiply it by the ratio we're going to need. I can do the same thing. If I have 10 moles of O2, this time I'm going to divide by the 5. 10 moles of O2, and there's 1 P4 for every 5 O2. So I can see that I'm going to have 2 moles of P4 if I have 10 moles of O2 to start with. So this is normal stoichiometry. I'm going to skip this one. We'll talk about that later. If I was looking at this, some of you like to have a little more structured way of thinking about things, because the problems get harder. Now I have 1.23. I can't always do that one in my head now because they get harder. So if I'm doing a stoichiometry problem, I'm going to start with what I know. I know 1.23. But I don't write just 1.23 because that really doesn't mean anything without units and element. Always include your units, because we're going to get into some that are in grams or something like be in liters. We have to know what our units are. And then my element is mg. Second thing I'm going to do, I'm going to look and say, are my units in moles already? If they're in moles already, I go straight to the mole ratios. So for every 1 mg, I need 2 H2O. Third thing I'm going to do is set up my mole ratio to cancel out the substance I want. And I can see that this cancels out, the magnesiums cancel out, and I'm left with 1.23 times 2, which is 2.46, and that is moles of H2O. So I figured out the substance that I want using my mole ratios. That would be the methodology I would use. Try the following one on your own. See if you can figure this out. If I have 2.5 moles of C3H8, how much oxygen would I need, how much carbon dioxide, and how much water would be made? Use those mole ratios. And then there's some problems on page 304 in your book. The answers should be in the back of your book, so check your answers. Can you do it? Can you do it correctly? There's a couple of practice problems I've assigned you on your checklist. Those may not have the answers in the back, but try those. Can you do them correctly? I think you'll find the stoichiometry is not as hard as you think, because it seems like it should be hard. But if you follow your methods, starting with what you know, using your mole ratios, canceling out the units you want, you'll get the substance you want if you show your work every single time. So try those, be prepared to go over these in class and take a quiz on them and see where you're at with understanding.